Good morning. My name is Eric Miller. Give a quick introduction of myself before we start going over this project here. Very recent information security intelligence graduate, bachelor's program. I'm a former full-time firefighter paramedic, and prior to that was a United States Marine combat vet. So I switched over to cybersecurity at the suggestion of a good friend of mine that works in the government sector, and I'm currently working as a full-time SOC analyst. I got into this and I realized that I enjoy critical thinking, problem solving, working as part of a good team, and it's kind of carried through throughout my various career choices, and also with this project. So do a quick kind of executive summary overview of the project and its primary goal, and then I'm going to break this up actually into two videos just because of the time constraints, and then also just to make it a little more digestible depending on my audience. So the first video is going to be a high-level overview, just kind of general findings, and then the second video, my intent is going to be a more detailed walkthrough and kind of showcase what I came up with and kind of some troubles and troubleshooting along the way. So for this project, it was handed to me by Drs. Furstenberg and Ruba, and I would like to thank them for entrusting me with this and allowing me the freedom to apply their ideas and their requirements kind of in my own unique fashion as I learn things along the way, and I'd collaborate with them and figure out where I needed to kind of pivot and adjust my path moving forward. So the project is going to be data mining ISIN internship reports using natural language processing and machine learning. The goal being to extract actionable keywords, ideas, and intelligence with the intent of shaping the ISIN program moving forward, as well as determining the quality of the individual student internships. So with that being said, the high-level overview, the terms that we're going to use: natural language processing. It's a field of artificial intelligence and computational linguistics. It allows machines to process, analyze, and derive meaning from text and speech data. Machine learning, the subfield again of artificial intelligence, uses algorithms and models to enable the computers to learn, make predictions and decisions without specific explicit programming. The machine learning algorithms and models, this is kind of a gray area, especially with being very new to the subject matter. Primarily, algorithms are the procedures that are implemented within the code and run on the data, whereas the models are more so the output from those algorithms, and they can be kind of collections of algorithms. Like I said, there's some gray area, and that could be partly on just my understanding of it to this point. We leveraged the Anaconda platform, Jupyter Notebook, as you can see here, and any necessary libraries that I found along the way to accomplish the task. So I was initially given 9 weeks worth of student reports in DOCX and PDF formats. Moving forward, it sounds like that's going to be CSV format, which is going to make things easier. However, if this is ever brought over to another department, or for whatever reason there's kind of outlying different formats that need to be put into CSV in order to be ingested, I had to come up with some scripts to make that happen. So the student internship reports consisted of primarily 5 questions, and that's kind of what our actionable items were coming from. So with that being said, let's kind of start going through here. This is a documentation. More so, this is going to be for whoever I hand this off to, whoever wants to take this over from this point. And there's going to be notes in here. Like I said, this is going to be more so for the detailed walkthrough, but quick going over this. So natural language processing, First, I had to convert the DOCX PDF files to a CSV, and I brought all of the reports into a single CSV file. From there, we do the pre-processing, and the reason for that is so that you can take out and strip down these reports into a format that is more easily understood and able to be used for the modeling and the machine learning portion. So you have the questions here, and this is, I believe these are going to be changed, and I'll talk about that a little more going into the detailed portion, the second part of the video. But you have the questions, and from the answers is where we're getting our actionable items. These are the quick scripts that I came up with, PDF to DOCX, and then DOCX to CSV. I tried initially doing PDF straight to CSV. It didn't work out so well, so kind of roundabout way getting everything into CSV. And then I have this here, start here if it's already in CSV format, which moving forward again sounds like that's what it's going to be. I have all the libraries that I imported that obviously can change depending on what happens going forward. You're going to load the data so that then you can create a data frame and start working with it. Cleaning the data, different processes here. You can kind of do this. The format that I did this in can be changed. This is just kind of what I ended up with. So you're going to remove punctuation, special characters. You're going to remove stop words and the, is, things like that. And you're going to tokenize and limitize. And I had to combine these functions. So this is going to split it up into individual words, apply limitization, basically reducing words to their root form. Again, the detailed overview, second video, will go over that a little better. Join them back together. And then here we're going to apply vectorization, and this is kind of leading into the machine learning portion, also known as feature extraction. What I chose for this was primarily the TF-IDF vectorization process. And this right here, even still to me, not 100% sure, the integers that we're getting here as far as how they're applied, but it does work out in the end here. So then we did some data exploration, and this is prior to actually attempting the machine learning portion. So word clouds, this is first applied to the entire document, and again this is all 9 weeks, everything brought into a single CSV and applied to each column with the column name above. Some of these could be stripped out. You have the name, major, obviously that's going to be pretty straightforward there, and then you start getting into the questions. So these are some of the primary words that stuck out, and brings them into a visual here. So you can go all of them together, especially if we start adding in more questions and answers. And then just wrote a quick script here where you can actually choose which question word cloud you want to view here. And for this one it was the second question. So you get a single visual here of that. Frequency distribution, again we're just kind of doing some data exploration of what we have here. And for this, most common words, we're picking the 10 most common, and then their count. So you have all those there. Keyword extraction, then you have for each column, keywords, major, that's obviously again going to be pretty much the same for each question, top 5. And then this is my weak area. This is where I'm still learning quite a bit on machine learning. I I have the notes here, primarily what I came up with when speaking with Dr. Furstenberg, Dr. Ruba. Named entity recognition, the intent being to extract the people, organizations, locations, just so we can have some specific identifiers in there. This again can be changed, but that's kind of what I was working with here. Topic modeling, we use the LDA algorithm, and it's just going to identify some main topics that are present throughout all the reports. You have the key themes and ideas, and then we have sentiment analysis. This one, I think, potentially could give us some more actionable items as opposed to the others that we can actually work with to shape things. This one, you've got the positive, negative, and quick viewing over these. So named entity, this one I actually redid. You can see in the notes here the original scripts, and this is where stumbling along the way, learning along the way, what I originally had was not true machine learning. So then I kind of went back through, redid the script. I'll rerun it, but you can see the original output here. It's misidentifying some stuff. Here, agile management, sprint organization, that's obviously not correct. Jukebox plan is a person, so that's where I went back, changed some things, and we'll go over that in the detailed video. Topic modeling, again, this is probably going to have to be changed. So you have I created a second script here to test for the second go around, and then sentiment analysis. So here you've got the negative, neutral, positive, and you can see in the questions here, and this also is probably going to have to be redone because you have the individual, the question, and then the general sentiment. So you have, this one's neutral, student, question, this one's neutral, you got positive, negative, and without going through and figuring out exactly where this was pulled from, obviously we can probably determine whether this is accurate or not, whether this was actually a negative statement or more so neutral, and we can kind of adjust going from there. So again, without trying not to go into too much detail, that's the general overview of everything that I got done in this given time frame. There's still a lot to be done going forward, a lot that can be done to make this a lot more rugged, and just kind of make it overall better. But I think it's a good starting point for to pivot and start improving on it. So yeah, detailed video will be next. Again, thank you for letting me take on this project, giving me the freedoms that I was given. And if you want to stick around for the next video, the detailed video, then I will see you there. Thank you again.